Hello to another math video. This time it will be about differentiation. If you want more Gavilan tutoring, visit the Gavilan Writing Center to reserve it in person. Or you could go to WConline to reserve it online. Support the Writing Center since it allows for these online resources to be put out there and help you anytime you want. Derivatives are the instantaneous rate of change. Instantaneous rate of change. Now, I recommend you write it with me because you should not forget this. In other words, they're the slope of any 2 points on a graph where the distance between the 2 points is infinitely small. Now, let me show you what I mean. Here we have the graph of the function, let's say y equals x squared. What would the slope be between these 2 points? Choose another color. These 2 points. Okay, with the 2 points being x and a. 2 points being x and a, and the distance between them being h. What would the slope be? It would be around like this. Okay. Well, what if a was here? What would the slope be now? What if a was here? What if the distance h was infinitely tiny? That would give you the slope close to that point x, but not exactly at that point. However, in calculus, if I can say any distance h, and h can be smaller than that, then we can count it as being the slope at this exact point. How does the derivative tie into this? Well, the derivatives gives you the instantaneous slope at point x. Let's take a look at this. Now, when I first started, I didn't recognize what this meant. Although it didn't harm me at the time, this form becomes crucial to understand as it will show up again and again through your calculus journey. The dy is the tiny change in y, and the dx is the tiny change in x. And dy dx is just the ratio of these two changes, which gives you the slope. That's right, dy dx is just a slope formula. So how does the formula for differentiation work, you might ask? Well, if you have a function x to the power of n, to differentiate this function, all you have to do is move the exponent to the coefficient and then subtract 1 from the exponent. So in the example, y equals x squared, and I encourage you to pause this video and try to figure this out yourself. What would the derivative be? Well, the derivative would be 2x. 2x. What does this mean? This means to calculate the slope at any point on this graph, you just plug in the x value, multiply it by 2, and that'll give you the slope. Now I have another question for you. What is the derivative of 2x? If you said 2, then you're right. You multiply the exponent of 1 to the coefficient, and then you subtract from 1, giving you 2 times 1 times x to the 0, which gives you 2. Now, a bit of a trick question. How many differentiations will it take to get the square root of x to equal to 0? And remember, the square root of x can be represented as x to the 1/2. I'll give you some time. So, if you try this yourself, you might come up with the answer of never. The reason this is a trick question is because the square root of x will never be 0 no matter how many times you differentiate it, because if you keep subtracting 1 from the numerator, minus 1, minus 1, minus 1, it'll never let you get the constant alone which means it'll never become 0. Speaking of 0, how about the derivative of the constant 2? Now, if you said 0, then you are right as well, because 2 is like 2 times x to the 0. Now, if you multiply the 0 by this, it'll be 0. Here's an example of a question you might get. So you are given the function of x cubed minus 3x minus 2. So that function looks about like this. Now, what is the equation of the line tangent to the point x equals 2? So let's go through this step by step. You differentiate x cubed minus 3x minus 2 to get 3x squared minus 3. All right. Now, to find out what the slope is of the line at x equals 2, you would plug in 2 into the equation. You'd get 2 squared minus 3, which gives you 9. Now you might be asking, well, how do we get the equation of the line tangent to the point x equals 2? Well, this is where our good old trusty point-slope formula comes in. And just to recap, if you don't remember, point-slope formula is y minus y1 equals m of x minus x1. And to get this y1, you just you plug in 2 to the original equation right here. And if we plug in 2, the answer is 0. And as we could see, at x equals 2, there's x-intercept, meaning y is 0 at that point. But still moving through the equation, we get y equals m of x minus x1 plus y1. It's just good to rewrite it. Okay, we plug in 9 for m. We plug in 2 for our x, and that's our x value, and 0 for the y, and we get y is equal to 9 x minus 2. And if you plug this in a calculator, you'll realize that this formula completely is tangent to the point x equals 2 on this function. Now, to me, that is very interesting. And this is why I think that derivatives are great, because they are precise. They are local. They are the foundation for analyzing motion, optimization, growth, decay, and any process that changes. Now, differentiation isn't just a technique. It's a lens. It's a way of seeing how the world evolves, one moment at a time. Now, if you're drawn deeper to the structure of mathematics, this is where it begins. Now, in my next video, I'll be going over limits, the limit variation of derivatives, and how to differentiate trigonometric functions such as sine, cosine, tangent, maybe even cosecant, secant, and cotangent. Thanks for listening. I'll see you in the next one.